Alright, welcome to this video on solving systems of linear inequalities by graphing, and we'll just jump right into it. When would I use this? Why would I use this? Well, I'm back in middle school, time travel, having a party with boys and girls, and I want at least 30 people at my party. And you know what? I'm going to go ahead and do the well, everybody says boys are X and girls are Y. So I'm just saying that I want at least 30 people, so x plus y, the number of boys and the number of girls, has to be at least 30. So I want greater than or equal to 30. There's one of my linear inequalities. And then my mom says that she can't handle all the drama associated with the girls. Sorry, ladies. So keep the drama level at 50 or less. Girls add a drama level of 5 each. So 5 times the number of girls will give me my drama level, and 2 times the level of, a level of 2 for each boy. And she wanted me to keep the drama at less than 50, less than or equal to 50. So here's my linear inequality statement, and I can go through a series of graphing that and bring it back to my mom and show exactly what I'm planning to do, and it'll probably come out with something like this, and I'll be able to determine how to meet both criteria, keeping it above 30 but keeping the drama level below, and I'll have a nice little feasible region that'll tell me how many girls and how many boys I can invite, and I'll have some options there. So that's kind of cool. So next time you plan your party, I doubt you're going to do that, but anyway, a little bit unrealistic, but you know. Let's see, so here's a learning card for this, systems of inequalities, and basically what we're going to do is we're graphing 2 sets of linear inequalities, and then we're just going to compare the shading on those to find the feasible region. All right, this first one, so here are my linear inequalities. This first one is already in what we call a slope-intercept form, so I don't need to change that. I'm just going to use the y-intercept to start graphing it, so I'm up here at 3, and I'm going to use the slope, which is 2 over 1, so the slope is coming from over here, and I'm going to go from that y-intercept up 2 and over 1, up 2 over 1, kind of went off the graph. I can also go down 2, which would be a negative 2, and left 1, which would be negative as well. So negative 2 over negative 1, really, as you can see, negative divided by negative is a positive, so that's the same thing as 2 over 1. Down 2, left 1, down 2, left 1. And then I'm going to draw my line, or am I going to do a dotted line? All right, well, I'm going to do a solid line here for this linear inequality because it said greater than or equal to. All right, and then I have to determine where to graph it. And one of the most common ways to do this is to pick a point on either side of this line. So I'm either going to graph shade it on this side, or I'm going to shade it on that side. All right, so we need to figure out which side to shade in on, and one common point to pick is 0, 0. I'm going to test that. That's x and y. I'm going to test it back in the original inequality. So I had y was greater than or equal to 2x plus 3, and I'm testing 0, 0. So I put a 0 in for the x, I put a 0 in for the y, and I simplify. I'm not solving for anything at this point. I'm just simplifying each side. 2 times 0 just goes to 0, so it's plus 3. Is 0 greater than 3? I don't know. Would you rather have $0 or $3? Well, this is not true. 0 is not greater than 3. So 0, 0 is not part of my solution for that linear inequality. So I'm going to shade on the opposite side. So I'm shading over here instead of on that side. So this, I wish you had that on your paper. Nice ability to shade that. And that represents the solution to the first linear inequality that we have here. Now I'm going to do a little erasure here, get rid of some of this. And I'm looking at the next one. The next one is not in slope-intercept form, so I'm going to put it through my little meat grinder here, which pops it out in slope-intercept form. Well, let's see, there's magic behind it. It looks like magic, but it's really not. What I'm doing is I am solving it for y. At least this is the approach I'm taking on this. I'm going to add 6x to both sides, and I get negative 2y greater than or equal to 6x minus 4, and dividing by negative 2 on both sides, and when I divide it by negative 2, it flips the inequality. Ooh, that's a critical thing. And we got 6 divided by negative 2 is negative 3x plus 2. I'm just negative divided by negative and simplifying it. So here's my new inequality after it's been converted. So I run it through here, out pops the new inequality. Now I'm ready to graph it. I've got the y-intercept and I've got the slope. The slope is not in fraction form, but I can convert it to fraction form. And I'm going to start at the y-intercept. Ooh, that's where they cross apparently. And it goes down 3 over 1. Down 3, got a little messy there, over 1, down 3 over 1, or up 3 over 1. And then, you know what, I'm going to do a dotted line this time because it just said less than, it didn't say or equal to. Now what if I had messed up and I forgot to flip that symbol? Well, here's where I'm going to catch it. I'm going to again test 0, 0 and check it in this. And I'm going to go back to the original equation, or I'm sorry, the inequality, the original inequality, and test it in there. All right, and give myself a little room. Negative 6 times 0 minus 2 times 0. And you're really going to see why it's so easy to use 0, 0, because 0 times negative 6 is 0. Negative 2 times 0 is 0. So it ends up being 0 greater than negative 4. Is 0 truly greater than negative 4? Well, it is. Therefore, the shading is going to be on, sorry, let me adjust this a little bit. The shading is going to be on the side with 0, 0 because it made the statement true. Don't like the way that happened. Made it true, so I'm shading on this side of the inequality. And the true answer to this whole thing is right over here where the shading was doubled up. Okay, that is the solution to my systems of linear inequalities. All right, well, I had the extra one I could have shaded on, but y-intercept, or I'm sorry, slope-intercept form is what was supposed to go there. All right, so this is where I would recommend you pause the video, give it a shot yourself, and then check and see. I'm going to go through them pretty quick and see if you get the right answer. Starting with this top one, it's already in slope-intercept form, so I'm starting up at 2. I'm going down 1 over 3. Why did I go down 1? Because of this negative. You know, you might say, does it go with this one or does it go with this one? It really goes with one or the other. So I could have, let's say I went up 1 and then I would have gone left 3 because of the negative I put with the 3, the denominator. All right, and I'm going to do a dotted line. All right, and then I got to decide whether I'm going to shade above or below that line. I say above or below. I'm going to on the 0, 0 side or the other side, and I'm plugging in 0 here, greater than or equal to negative 1/3 fractions, but it's going to zero out, plus 2, so it's 0 greater than or equal to 2 because all this just canceled out or became 0. Is 0 greater than 2? No, it's not. So where do I shade? I shade above. All right. And then the next one, it's in slope-intercept form, so that's nice. Looks like the slope is missing. Well, it's 1, or 1 over 1. Okay, so it's an understood 1 in front of that. I'm at negative 2 for the y-intercept. I go up 1 over 1, up 1 over 1, up 1 over 1. And you can see I'm going to do, again, a dotted line because it was just greater than, not or equal to. And then I have to determine if I'm going to shade on the 0, 0 side or not. So I go 0 greater than or equal to, well, 1 times 0 is just 0. So I've got 0 greater than or equal to negative 2. Is 0 greater than or equal to negative 2? It is. Therefore, I'm going to shade where 0, 0 lies and everything else on this side of the dotted line. All right. So you can see, kind of barely. All right. So you can see where the overlap is. That is where my answer is. It's this section right here. In there. All right, so hopefully you got that one right. Again, pause if you need to, and we'll give this one a shot. All right, now these are not in slope-intercept form, so I'm either going to convert them. Some people like to just plug in 0 for x and find out where the y-intercept is and the x-intercept and solve graph it from there. I might do that on the second one, but right now I'm going to stick with this method. Negative 3y. I'm subtracting x from both sides. It's still negative 3y. I divide by negative 3 on both sides. I get y, flip the symbol, 1/3 x, because there was an understood 1 in front of that, and plus 1, negative divided by negative. You can see that you really have to know your positive negative integer stuff to convert these to y form properly. So I start at 1, the y-intercept, and I go up 1 over 3, up 1 over 3, ran out of space. I can go down 1, left 3 as well, and I'm giving it a dotted line again. And then I decide whether I'm going to shade on the 0, 0 side or not. I'm going back to the original inequality. 0 minus, well, 3 times 0 is 0, greater than or equal to negative 3. I get 0 is greater than negative 3. Well, it is. So I'm shading on the 0, 0 side of this, which I'm calling the lower portion of the graph. All right. Then I'm going to the next one. Again, I'm going to get this into y form. I am subtracting x from both sides. That does not make the symbol change. It's only when you multiply or divide by a negative. I am not dividing by a negative, but rather a positive. So I keep the symbol, negative 1/3 x plus 3. I was just doing a little simplification here. And now I've got it in y form. I like doing it that way. I go plus 3 for the y-intercept. I go down 1 over 3, down 1 over 3, or up 1, left 3. It is a solid line this time because it was or equal to, less than or equal to, and now I have to decide where I'm going to shade it. So I put in 0 plus 3 times 0 is less than or equal to 9. 0 plus 0 is 0. Less than or equal to 9. Is 0 less than or equal to 9? Yes, it is. Therefore, I'm going to shade on the 0 side of this linear inequality. All right, and so you can see where the overlap exists, that of the shading, that is the solution to my systems of linear inequalities. So my answer is down here. Make that clear to your teacher where your answer is. You should double shade it. You know, you're not working with colors like this, but pencils. Some people do it with highlighters. That makes it nice. All right. Again, pause. I'm going to go and I'm going to go ahead and work this into y form. There are some people, well, I'll just show you this real quick. If you want to know, the y-intercept is where x is 0. So I could plug in a 0 for x here and find out where the y-intercept is. So this is 0, so I end up with a pretty simple linear inequality that says 3y is less than 9. I divide by 3 and I get y is less than 3. So at 0 for x, it's right here up at 3. Likewise, if I put a 0 in for y, 5x plus 3y, I'll find the x-intercept. So 5x less than or equal to 9. I divide by 5. This is the part I don't like about this. 9/5. Okay, so that's a little bit less than 2. It's 1 4/5 or 1.8. So the x-intercept is at a little bit less than that. I don't get exact, I don't know. You decide. So there's the line. Again, that's not my personal preference. I haven't done them that much in the past that way. Hopefully I didn't mess anything up. But I like to solve for y, get it in the slope-intercept form. Now I just need to go back and test. I'm going to test 0, 0. I put in 0 here. This is 0 plus 0. I do like them when they're in this form. It's just 0 is less than 9. 0 is less than 9. So I'm going to shade it on the 0, 0 side of that dotted line. And then I'm going to work the other one into y form. 3y, or slope-intercept form, less than or equal to negative x minus 3. I'm almost there. I just like this better. I know there's some teachers out there or some other folks listening going, no, you do it the other way. That's fine. Yeah, it's your personal preference. But so this one, negative 1, and I'm going down 1 over 3, down 1 over 3, up 1 over 3, up 1 over 3. It's a solid line. And then I've got to test 0, 0 back in the original. So 0 plus 3 times 0 less than or equal to negative 3. All this cancels out to 0 or reduces, simplifies to 0. 0 is less than negative 3. That's not true. 0 is not less than negative 3. It's more than that. So I'm not going to shade on this side, on the 0, 0 side. I am going to shade on the non-zero zero side, if you will. And then the overlap is, well, everywhere where it overlaps, so it's in this segment right here. I'm kind of, continuing this line. So it's all in this overlap section. That's where the answer is. All right. And we are at the you try section. Oh, we only have two of them. So one of them, they're both in slope-intercept form. The other one, you could work it into that or do that x-intercept, y-intercept method and take it to your teacher and see if you got the right answer.